Today we're going to look at the properties of logs. If you have not already, please do the warm-up with no calculator, pause this video, and then when you are done, restart the video so then you can check your answers. Here are the answers to the warm-up. Feel free to pause and check my notes and just make sure that if you have any questions, you do send me an email. Today, we're going to look at the different properties of logs, starting with the change of base formula. I've introduced this idea to you guys already when I talked about graphing and how some of you don't have that log base button on your calculator. You can take a log and change it to any base that you want, and the reason we do this is for using our calculators, being able to evaluate with different bases, and just graphing, different things that we can do with this. So if you have a log and you want to change it to base B, what you could do is you can rewrite it as the log of the argument over the log of the base. So in other words, if I wanted to change it to any base I wanted, I could rewrite this as log base B of x, that's my argument, over log base B of A, that's the original base. So I could do this with base 10 if I want. I can rewrite this and it would be equivalent to log x over log A. Notice in the first case, B can be any number. Here we're being specific and it's a base 10. You can also change it to base E. Remember, base E is the natural log function. This is all equivalent to the natural log x over the natural log A. So in the case of logs, this change of base formula, you can change a base to any number you want. You just have to make sure you put the argument on top and then the original base on the bottom. Now, this is helpful for, again, those of you that do not have that log base button in your calculator. If I said to graph this, just as a quick review, you would have to rewrite this as log x plus 3 over log 2. And then the same thing for this one. Now be careful because the plus 3 on this second example is not in parentheses. So consider this being the argument of the log. So you would have to be careful that you do log x over log 2 and then put that plus 3 on the outside. Now, even if you do have the log base button in your calculator, on our quiz, there is a question on the non-calculator portion where you are asked to know this. So even those of you who have log base, make sure you understand this idea. Now, how does that help us? If you were given a problem like this and you did not have, that log base, or just in general, you could rewrite this as log 12 over log 2 and you can evaluate it. So if you guys could please go to your calculators now and let's, without using the log base button, find what this quantity would be. So we can go to log 12 divided by log 2, and we can get that decimal approximation of approximately 3.585. Now, the cool thing about this is I actually could use natural log as well. Natural log 12 over natural log 2. And you'll see that if I use the natural log button, oopsies, natural log 2, I should get that same answer. So it is really cool that you can do it with either one of those. Same thing over here. We can do this. Now, I just noticed in the directions it did say something about how we can, we should predict what two values it'd be between first. So just think if I said 7 to some power equals 33, well, 7 to the first power is 7. 7 to the second power is 49. So I know that this exponent would have to be between 1 and 2. And as I just said, we can confirm this on our calculator using this formula. And we can see that log 33 divided by log 7 is equivalent to approximately 1.797, which is what we predicted it would be between. So just really cool property. Again, when you go to math, you do have that log base button on there. But if this was non-calculator and we asked you how to type it in, obviously you'd have to have some understanding. So you can see that if I actually typed in that problem we just did, you can get it this way too, but still know this property. Now, the other three properties that we are going to practice in great detail, again, properties you learned last year, are first of all, product property. If you ever have a log with a base and there's a product inside of the argument, you can rewrite that as log base b of the first part of that product plus log base b of the second part of that product, which in this case is y. Now, the quotient property says that you can do the same idea if you have a quotient in the argument, but instead of addition, oh my gosh, what is going on with my iPad? Log base b x minus log base b y. And then finally, the power property says that if you have a power on a log, you can actually move it to the front, and it's the same thing as that power times the log base b of x. Now, this one's really cool. I like this one a lot because when you think about this log base b, and let's just say it was x to the third power, think about how this is actually the same thing. X to the third is really the same thing as x times x times x. Now, if you go back to this product property, didn't we say that if there's a product, you can write it as the sum of the logs? So note that this would really be log base b x plus log base b x plus log base b x. And if you notice, there's three of them. 3 log base b x, which is exactly what this property says, is that if you move that power to the front, that's the equivalence. And it makes sense when you expand it using that other property, the product property, that we're seeing that exact thing. So for the next part of the notes, there's a lot of examples of this. We will do these examples together, and then you should pause, do the bottom examples on your own, and then check with Baki. So here we go. This first one, you're going to want to make sure you check the sign in between the logs and also make sure that they have the same base. If they don't have the same base, you can't use this property. Now, because they do, and I see the subtraction, we can rewrite this as log base 5, and then we're going to take the quotient of those two numbers. Always simplify. If you divide 75 by 3, or reduce 3 over 75, you're going to see that this is 1 over 25. You will notice in the directions underlined, it says evaluate. So once you get this simplified, you need to get a value for this. 5 to what power is 1 over 25? We'll think 5 to what power is 25, and then remember we want the reciprocal. Same thing with example 4. With number 4, we want to evaluate this, but let's use the properties to condense it first. If you ever have a number in front, you can bring it back as the exponent. So this would become log base 6 of 2 squared, which becomes 4. Then, since we have a sum, we can now rewrite this as the log base 6 of the product of these two numbers, 4 times 9, or 36. Again, evaluate. And we get this value of 2. 6 to the second power is 36. The next set of examples say to expand. Let me do a different color. But this time, there are variables as well. So when we're doing a problem like this, where we're expanding and we have variables in here, always look at the things that are happening with that argument and think about what is affecting every single term. This squared on the x only affects the x. This product on the top only affects the 5 and the x squared. But if you notice, this quotient affects the 5, the x squared, and the square root of y. So what we need to do is take care of the quotient first. We're going to rewrite this as the natural log of 5x squared minus the natural log of the square root of y. Now, I'll put that in parentheses. You may say, why? What I'm doing is I'm using this property right here, but I'm given something that looks like this. So I'm taking the log base b of the top and subtracting the log base b of the bottom. Well, that's what we see here. So the log of the top over the log of the bottom. But we have to subtract. Now, let's focus on this first one. I see a product. I can't take care of the power yet because it only affects the x. So I have to rewrite this as the natural log of 5 plus the natural log of x squared. Once I separate the product, then I can take this number and move it to the front. So I get the natural log 5 plus 2 times the natural log x. Over here, remember that the square root of y is the same thing as y to the 1/2 power. So I end up getting minus the 1/2 natural log y. And then I can just rewrite that down here as that answer. The next problem in this set is same idea. You will see that, again, we have this quotient that is affecting all of the terms. So what I'm going to do is I'm going to start by rewriting this as log base 2p squared minus log base 2 of that 2m to the 4th power. Now, for the first log, we're okay to move that in the front. 2 log base 2p. Over here, however, there's something interesting going on. It looks like this 4 is being raised, or this 4 is affecting both the 2 and the m. You have a couple options here, but what I think is the easiest option is to take this 4 and move it to the front. However, when you do this, you are going to have this product in the log still that you have to take care of. But every time you expand this, sorry, that's the word I was looking for. I'm trying to find a word there. Every time you expand this log, the negative 4 in the front will affect anything that you do moving forward. So we can rewrite the 2 log base 2p, but I'm going to put a negative 4, and in parentheses or brackets, I'm going to expand what's inside. Log base 2 plus log base 2m. But here's the thing. First off, log base 2, think circle of life, equals 1. But secondly, this negative 4 in the front needs to be distributed. So our final answer is this right here. The final 2 problems in the set, and then we are done for today, and then you can go ahead and practice those problems at the bottom, is the condensing. Condensing is basically getting the answer like we just got and working backwards to get the problem to look how this problem started. So basically you want 1 log. Same thing over here, 1 log, although you're starting with something very complicated. So with that said, think about what we did in these problems last, and that's what you want to do first. Remember I moved the powers to the front last? Well, let's take those powers and move them back. So I'm going to take this, move it back, take this, move it back, take this, move it back. So I'll get log base 3, x to the 5th, plus log base 3, 8 to the 1/3. We'll evaluate that in just a moment, minus log base 3, d squared. Now, from here, if you can evaluate, do so. 8 to the 1/3 power, we know is 2. And then you need to look for pluses and minuses. We can condense this all to 1 log with a base of 3. Anything that follows a plus sign is going to go in the numerator of this log function. Because think, this right here would become 2x to the 5th when I use that product property. Remember, we're working backwards here. If you think about it, we're taking something that looks like this, and we're working backwards to get it to look like that. So if that's the case, these two logs, I can make a product of this and this. But because this follows a minus sign, I need to take that d squared and put it in the denominator. And then we're done. Final question in this set, we have the 4 can be brought back, the 1/2 can be brought back, and we get natural log x to the 4th minus natural log of w minus 2 to the 1/2, and then I'm going to rewrite that natural log w. Now, we can't evaluate this. We can, if we want, write it under a radical, because remember, anything to the 1/2 power is the same thing as the square root of that quantity. But other than that, there's no work that we can actually do with that radical. So let's look for what follows minus signs, what follows plus signs. You're going to write 1 natural log, and anything that follows a plus sign, technically this is positive, is going to go in the numerator of that natural log function's argument. So I have this x to the 4th and this w. Now you may say, well, wait, they're not next to each other. Remember, we could reorder this. I mean, I have every right to take this and I can move it to the front. So really, when you think about it, I can take these two logs and I can make a product and put that in the numerator of this. Let's move that back. Anything that follows the minus sign, you're going to put that into the denominator of your natural log, and then we are done. So at this time, I ask you to practice these problems at the bottom and then check with the key that is posted